something like, I'm writing in white on white, which is really stupid. Something like 2x squared minus x plus 7. So when they say standard form, when you're checking your answers in the back of the book, your polynomial will be in the order where the highest exponent term is written first. So the x squared comes first, the x to the 1 comes second, and the 7 is called a constant because it does not have a variable. Alright, so I know you know that's a trinomial, right? Don't you have some that fact stored somewhere in your head? So you've done polynomials before. What's a one-term polynomial called? It has a special name. Monomial. If it has 2 terms, it's called a binomial. If it has 3 terms, it's called a trinomial. If it has more than 3, it doesn't usually have a special name. We just call it a polynomial if it has 4 or more terms. So you've done polynomials before. If we're finding the degree of the polynomial, in example 1, I don't know why my examples are not up there. Maybe they're on the next page. Let's check and see. Or they may just be gone completely. Is that those? If you're finding the degree of the polynomial, let's put it in standard form first. It's not in standard form. So example 1, what term would come first? 6x to the 4th, and then minus 3x cubed, and then minus, or not, plus 2x, and then minus 5. So in part of your homework tonight, they're going to ask for the degree of the polynomial. They're going to ask for the degree of the polynomial. So if you have 1 or more terms, all right, and we do, you're going to pick the term that has the highest degree. So, and that's the one that you'll write first if you put it in standard form. So the degree of this polynomial is 4, and that's just because 4 is the highest or the largest exponent that we have. That's how we name the degree of the polynomial. Once we learn a lot of Algebra 2, we can tell about the degree of the polynomial. If we go to graph it, we can tell what the ends of the graph are going to do, what the graph's going to look like. The degree tells us how many solutions the equation has, so the degree ends up being very important later on. Your leading coefficient is probably what you think it's going to be. Y'all want to tell me what the leading coefficient is? 6. Your leading coefficient is going to be the coefficient that's being multiplied times the term that has the highest exponent. Alright, I chose example 2 to show you what happens when each term has more than one variable. Alright, this one is pretty hard to put in standard form, and I probably won't ask you to put example 2 in standard form, but let me remind you that if a term has more than one variable, we won't put this one in standard form because it's got different variables in it. But you take the first term and you look at all the exponents. So in the first term, 4xy squared, the exponents are 1 and 2. So the degree of that first term, you find that by adding your exponents together if there's more than one exponent in the term. So 1 plus 2 is 3. So the degree of the first term is 3. Go to the next term. Your exponents are 1, 1, and 2. Add all those up. 1 plus 2 is 4. So the second term has a degree of 4. Go to the last term. Your exponents are 2, 2, and 2. Since there's more than one variable, you'll have to add up all the exponents of your variable, and that term has a degree of 6. So the degree of your entire polynomial is the term that has the highest degree. So if we wrote this one in standard form, 5x squared y squared z squared would come first, and then the minus 10xy z squared and the plus 4xy squared. They're really not making you write it in standard form. You could, okay? So the degree would be 6, and the leading coefficient would be 5. All right, questions about how you find the degree of a polynomial? Example 1 is when you just have one variable, and example 2 is when you have more than one variable. All right, we are going to learn how to add, subtract, multiply polynomials. We'll review that. Okay, so example 3, we are adding. Okay, when you are adding, You literally drop the parentheses and you combine like terms. So you could drop the parentheses and rewrite all that, but there's no reason to do it. So all we do is think of ourselves as dropping the parentheses and combine like terms. So I have a negative 9x cubed and a positive 13x cubed. Those combine to be 4x cubed. And I'm going to go ahead and write my answer in standard form. So I'm going to combine the terms that have the highest degree first and then go in descending order from there. 7x squared. Do I have any other x squareds? Nope. So I just bring down a plus 7x squared. Negative 5x and negative 8x combine to be negative 13x. And then I have that little 3. And I just bring down plus 3. So when you're adding two polynomials, nothing changes. No signs change. You just combine like terms. All right, example 4 is showing you what we do when we subtract two polynomials. So in example 4, you have to remember on the polynomial that you are subtracting, you have to distribute an understood -1. On the polynomial that you are subtracting, you have to distribute a -1, or another way to say that is you have to change all of the signs inside the polynomial that you are subtracting. So I would rewrite this one. So I'm going to have everything in the first parenthesis stays the same. And then once I distribute the -1 into the second parenthesis, I get a negative 2x cubed, a positive 6x squared, a positive 3x, and a negative 9. Then you just find your like terms and combine them. You must distribute the -1 when you are subtracting a parenthesis or subtracting a polynomial. We'll combine in order from the highest exponent to the lowest, so we'll combine our x cubes. What does that give me? 5x cubed. Then we'll go to our x squareds. Those combine to be, I have a -8 and a positive 6. So it gives me a negative 2x squared. I have a 9x and a 3x. Those combine to be 12x. And then I have a negative 6 and a negative 9. That combines to be negative 15. So example 3 is showing you what you do when you add parentheses. You don't change any signs. You just combine like terms. Example 4 is when you subtract. And you have to change the signs of everything in the second parentheses. Questions about 3 or 4? All right, in example 5, we're multiplying. We've really already done this. Example 5 is a monomial times a monomial. It's a one-term polynomial times a one-term, so you just multiply the coefficients together. -8 times 5 is negative 40. You multiply your x's together by adding the exponent, so you get negative 40x to the 9th. You've really done that before, already in this chapter. Example 6 is a binomial times a trinomial. So this one's going to be a little bit harder. So anytime you have a binomial times a trinomial, you're just using the distributed property, and you're going to start with your 2x, and you're going to distribute your 2x into the second parentheses. So we're multiplying, so we're adding exponents. What's 2x times x squared? 2x to the third. 2x times 4x. 8x squared, 2x times 5, 10x. All right, now there's a 3 that you also have to distribute. So you're going to multiply everything by 3, and you're going to get plus 3x squared, plus 12x, plus 15. And then you're going to combine like terms. What's your highest degree term? 2x cubed. Any more 2x cubes to combine that one with? Nope, so I just bring that down. The next term is 8x squared, and I have a 3x squared to combine that with, so that's going to give me a plus 11x squared. My next term in descending order is the x's, so I have a 10x and a 12x. They combine to be 22x, and then I have that little constant term that has no other constant term, so you'll just bring down your 15. All right. Example 7 is a binomial times a binomial. Your Algebra 1 teacher may have taught you to FOIL, F-O-I-L. Okay, foiling is really just distributing. Once you get to Algebra 2, that word only applies to a binomial times a binomial, so I like for you just to think about you're still just distributing. So you're going to do 3x times 5x and 3x times negative 3. That's 15x squared minus 9x. And by the way, that's multiplying the first terms and the outer terms. Somebody just came up with FOIL. And then you've got to multiply everything in the second parentheses by 4. That gives me 20x minus what? 12. So distributing a binomial times a binomial is really multiplying the first, the outer, the inner, and the last. But that four little word only works for binomial times a binomial. So I like to just talk about distributing. I do have some like terms in the middle, so my final answer will be 15x squared plus 11x minus 12. Any questions about example 7? All right, example 8 is a binomial times a binomial. You can use the FOIL method, but we're still just distributing. So we take the 2y and we multiply it times everything in the second parentheses. 2y times 4y is 8y squared. 2y times 3z. Now we can't multiply y times a z because the variables are different. So we'll just push them together in alphabetical order. So 2y times 3z. 2 times 3 is 6. So you'll have a plus 6. And then you'll just push y and z together in alphabetical order to show multiplication. If they're two different variables, you just push them together and you put them in alphabetical order. All right, then we'll come back and distribute the negative z. Negative z times a positive 4y is a negative 4yz. And then a negative z times a positive 3z is a negative 3z squared. Any questions before I combine like terms and how I multiplied those together? A little bit harder when you have two variables. You have any like terms? Yep, these two middle terms are like terms because they both have a y times a z in them. So you're going to bring down your 8y squared, combine your two middle terms, that's going to give you a positive 2yz, and then bring down your minus 3z squared. That would be your answer. Any questions about multiplying? Any questions about multiplying? All right, we do have some shortcuts that we like to use once we get to Algebra 2, and you may or may not have been taught these in Algebra 1. But example 9 shows us how to multiply a plus b times a minus b. All right, you have heard me call these conjugates before. Maybe not a lot, but maybe I use that word. So let's go back to something that we did with the square root section. In the square root section, just to kind of show you how we did this, if we had 1 plus the square root of 3 in the denominator, what did we multiply by? We multiply by 1 minus the square root of 3. 1 plus the square root of 3 and 1 minus the square root of 3, those are called conjugates because they're exactly the same. They're a binomial. They're exactly the same except their signs are opposite. So that's what you're doing in example 9. It says a plus b times a minus b. Anytime you're multiplying two binomials that are exactly the same except the signs are opposite, you don't have to multiply out the long way. You don't have to multiply 4 times because the two middle terms are always going to cancel. So when you notice you have conjugates, like you do in this example, 2x plus 3 times 2x minus 3, see that those are conjugates? One's got a plus, one's got a minus. You don't have to multiply it out the long way. You just have to multiply 2x times 2x, and they're showing that as 2x squared. And then you do positive 3 times negative 3. All right, let me just prove to you real quick. I'm going to show you this one the long way and show you why we have a shortcut. You don't even have to work this out. Just watch me. So if I do this the long way, I get 4x squared. What? Negative 6x. Keep going. Positive 6x and negative 9. And what happens with the negative 6x and the positive 6x? They're going to cancel, and you're just going to get 4x squared minus 9. So when you're multiplying two conjugates together, you don't have to multiply 4 times because the two inner terms are always going to cancel. That's only true when you have conjugates. All right? Everybody understand what conjugates are? They're binomials that are exactly the same except for the signs. So that's a shortcut there. Example 10 is squaring a binomial. So anytime you have a binomial squared, you have this little shortcut. And I do want you to write these words. It's square, I'm just going to abbreviate, square, double, square. When you're squaring a binomial, when you have x plus 3 squared, y plus 5 squared, when you're squaring a binomial, there's a shortcut called square, double square. Does anybody remember that from Algebra 1? Is that taught to you in Algebra 1? Okay, it's a very quick way to square a binomial, and you're going to need quick ways when you get to Algebra 2 because your problems are going to be really long, and you're just going to want to do y plus 5 squared in your head. All right? So that's your binomial squared. So according to the shortcut, we're going to square the first term. So we square y. That's where you see it right here, y squared. That's the square part. We're going to multiply and double. In the second step, we're going to multiply y times 5, and we're going to double that. That's the double part. You're going to multiply and double, and then you're going to take the last term, which is 5, and you're going to square it. So you're going to square the first term, you're going to multiply the two terms together and double that. That's why the 2 is there. 2 times y times 5. And then you're going to square the last term. And you'll actually do this shortcut in your head. You'll square the y, you get y squared. You'll multiply y times 5, that's 5y. You multiply that by 2, or you double 5y, that gives you 10y. And then you square the 5, 5 squared is 25. So you'll actually do square, double square in your head. All right. Right underneath a plus b squared is a minus b squared. It's still the same thing. Square, double square. We'll actually look at some examples in just a second. Example 11, I actually don't make you memorize this. We do not use this a lot. If you want to memorize it, you can. We don't usually have time to take it out and actually show you how to memorize cubing a binomial. I'll show you actually how I cube a binomial, but I do want you to know how to do 9 and 10. You do need to know how to multiply conjugates with a shortcut, and you do need to know how to square a binomial with a shortcut. All right, let's apply these rules or these shortcuts to the last 3 examples. All right, you do not have to memorize cubing a binomial, but I do want you to know how to do sum and difference of 2 terms, those are called conjugates, and squaring a binomial. So let's look at these last examples and we will be done. So example 12 is an example of conjugates. You have x plus 5 times x minus 5. So the shortcut is multiply the first 2 terms together, that gives you x squared, and multiply the last 2 terms together, that gives you negative 25. It's that easy. If you multiply those out the long way, what's going to happen to the 2 terms in the middle? They're going to cancel. So why multiply them if you know they're always going to cancel? All right, example 13 is an example of a binomial squared. So you might want to write that down. This is a binomial squared. Anytime you have a binomial squared, your shortcut is square, double, squared. And you'll actually do this in your head. It'll be hard to begin with, and then once you practice it, it's going to get better. So anytime you have a binomial square, the shortcut is square double square. You take the first term and you square it. 2x times 2x is 4x squared. The double is the hardest part. You're going to multiply the two terms together in your head. What is 2x times negative 7? Negative 14x. You're going to double that, so that you're going to multiply it by 2. So negative 14x times 2 is negative 28x. And then you're going to square negative 7. Negative 7 times negative 7 is positive 49. I'm going to go over that one more time. You take the 2x and you square it. So 2x times 2x is 4x squared. You multiply 2x times negative 7 in your head, or you go over to the side and you write that down if you can't keep it in your head. 2 times negative 7, 2x times negative 7 is negative 14x, and then you double that. You can multiply it by 2, or I like to actually, I'm visual, I like to see 2 of those. You're doubling negative 14x, so that's how you get negative 28x, and then negative 7 times negative 7 is 49. All right, you try one. You try one. Let's do 3x plus 5 binomial squared. 3x plus 5 binomial squared. Square, double square. Give you a couple minutes to think about it. Who's got an answer? Anybody? Okay. Plus 30x, good. Plus 25. Okay. It's usually the middle term, the double part, that's the hardest. I'll go over it one more time. The first term, you square it. 3x times 3x is 9x squared. Then you multiply your two terms together. 3x times 5 is 15x, and then you double that. You can actually put two 15x's down in your head, or you can multiply that term times 2. And that's how you're going to get the 30x. And then you take the 5 and you square it. 5 squared is 25. All right, last problem is a binomial cubed. If you want to memorize the shortcut, you can, but I don't usually make people memorize the shortcut for a binomial cubed. So how I teach it is I teach you to rewrite y minus 7 cubed, okay, as y'all all agree that's y minus 7 times y minus 7 times y minus 7. That's what that means. So you could actually rewrite it as y minus 7 times y minus 7 squared. You can either memorize the shortcut, which is a little bit difficult, or when you're cubing a binomial, you're going to rewrite it as y minus 7, that's 1 y minus 7 times y minus 7 squared. And then you're going to do your shortcut on y minus 7 squared because it's a binomial squared. So you're going to bring down your first y minus 7, there's nothing to do there, and you're going to square the second y minus 7 using our shortcut square double square. So the first term squared is y squared. You're going to multiply the two terms together, and then you're going to double that. So y times negative 7 is negative 7y. Negative 7y doubled is negative 14y. And then you're going to square negative 7. Negative 7 times negative 7 is positive 49. So what I do is I just do my square double square shortcut, and then I have a binomial times a trinomial, which we've already went over, and we'll just do that the long way, okay? Unless you want to memorize the shortcut. So you're going to take this first y and you're going to distribute it into the trinomial. So y times y squared is y cubed. Y times negative 14y is negative 14y squared. Y times positive 49 is positive 49y. Then you're going to go back and distribute the negative 7. Negative 7 times y squared is negative 7y squared. Negative 7 times negative 14y is, somebody help me out, positive 98y. Thank you. And negative 7 times a positive 49, need help there, is a negative 3 what? 343. Have any like terms? Yeah, we have two terms that are y squareds, and we have two terms that are y's. So once we combine our like terms, we'll be finished. So our final answer is y cubed. Next term. Minus 21y squared. Third term. Plus 147y. And then you just bring down that negative 343 because there's no term to combine it with. Alright. If you want to memorize the shortcut, it's on your notes, and you can go back and memorize the shortcut for squaring a binomial, but cubing a binomial. We don't cube binomials a lot, and most of my students never use that shortcut enough to keep it memorized. Questions?
So, like, on the quiz or on the